by this Sokolov, I study the role of meridional circulation of solar activity. I use Parquet dynamo model and develop a synthetic method for solving equations of the Parquet dynamo with meridional circulation. I consider the simplest kinematic Parquet dynamo model. Complex model do not give detailed information about the role of every component. I consider the simplest model to understand of influence of meridional circulation. I have a series of work devoted to this issue. I will to tell about the main result of my work. I recall the mechanism of Parquet dynamo. Parquet presented a functional scheme, a toroidal magnetic field produced from the poloidal field by the action of differential rotation. The inverse process of transforming toroidal magnetic field into a poloidal field is realized by the action of alpha effect. It is Parquet dynamo equations. B is the toroidal magnetic field. A is proportional to the toroidal component of the vector potential, which determines the poloidal magnetic field. Theta is the latitude measurement from the equator. D is dynamo number. Module D is minimum units. The simplest solar dynamo models predict activity cycle that are too short. Duration cycle is 10 times smaller than the observed value. In order to wave spread slowly, that something should prevent its movement. We can imagine a similar situation. It is against the window harder to go than to go in the direction of the wind. It is meridional circulation that is the wind for the dynamo wave. Moreover, there are observational data confirming its existence. Structure of meridional circulation is not known exactly. We examine the effect of solar meridional circulation on the propagation of dynamo waves depending on the type of matter motion in a Parquet approximation. It is Parquet dynamo equation with the meridional circulation. It is meridional circulation. It is function of theta. We seek a solution in this form. S, mu and nu are smooth functions, and module D is many more units. We used an approach which is similar to the WKB technique. S is the analog of the action. It is derived K corresponding to momentum of wave vector, which complex in our case. Upon substituting the chosen form for the desired solution, the system yields of algebraic system of equator for mu and nu. The solvability condition for this system is a Hamilton-Jacobi equation. Here we can see a real and imaginary part of gamma as function of V. The complex quantity gamma determines the energy value. Its real part gives the growth rate, and its imaginary part gives the duration of the activity cycle. The meridional circulation substantially prolongs the activity cycle. It is equal frequency of cycle. It is equal 1 divided by period. The meridional circulation does not make it possible to reverse the direction of propagation of the dynamo wave. Here you can see topology of the branch of wave vector for meridional circulation is less than critical V. Dynamic waves, here the solution is smooth and dynamic wave is traveling wave. It is profiles for meridional circulation. We consider it. Dynamic wave becomes to steady growing magnetic field if meridional circulation is more than 3 divided by 2. The smooth solution exists for such meridional circulation if we use this gamma and this gamma. The smooth solution exists for such meridional circulation if we use this gamma. It is smooth solution, it is no smooth solution. We have shown that the length of the cycle depends on the meridional circulation at the joint point of the wave vector branch, which describes the propagation of the waves from the poles towards the equator. The latitude profile of the meridional circulation affects the cycle length. Consequently, small change in the profile of the meridional circulation can considerably change the magnetic field. Growing magnetic field can be transformed into a traveling wave, and vice versa. It is important that this does not require any considerable change in the differential rotation. The F effect of the amplitude of the meridional circulation. In the model considered, meridional circulation equal 1 corresponds to 11 years activity cycle. Since such a we have such value for meridional circulation and such a value for critical V. For such dynamo number, according to the observation, typical meridional circulation reaches such a value. At altitude, this circulation can reach such value. Note that observation indicate V is more than V critical at middle latitudes, while we have found here that the magnetic field grows without oscillations and the meridional circulation exceeds its critical value. This growth of the magnetic field can apparently stimulate some active solar object. Observations show that the appearance of such object is accompanied by the considerable increase in the magnetic field. Thus, when the nonlinear dynamo retards the growth of the magnetic field rapidly enough, fast retardation of the wave, this can result in the appearance of active solar object. When the growth persists for a long time, a slow retardation of the wave. This can result into a global reconstruction of the solar activity and, in particular, Maunder minimum. Note that in the model proposed that transition from one regime to another can be due to change in the latitude profile of the meridional circulation. Next problem, meridional circulation and solar activity, solar cycle according to surface large scale magnetic field data. A solar cycle is describing the spread of the activity wave, which is visible primarily on the latitude temporal distribution of sunspots. Such waves spread from the middle latitude to equator. Appearance of sunspots associated with this wave. This phenomenon is illustrated well known butterfly diagram for sunspots. Butterfly diagrams represent the toroidal magnetic field. At the same time, the mechanism of solar dynamo is based not only on the toroidal magnetic field, but also on the poloidal magnetic field, it is difficult to understand how the butterfly diagram for the poloidal magnetic field looks in reality. The bulk of the magnetic flux collected in small area structures. Therefore, it is difficult to distinguish the large-scale poloidal magnetic field. Some problems arise then the number of sunspot groups associated is considered as a tracer of the toroidal magnetic field. The directly responsible for the solar cycle magnetic field is located the depth of the conductive zone, and such magnetic field is not directly observable. Therefore, the large-scale surface magnetic field can be considered as better tracer of poloidal magnetic field. It is latitude time diagram for the radial magnetic field calculated in the potential approximation for the magnetograph data. The butterfly diagram of large-scale magnetic field are markedly different from the butterfly diagram constructed from the sunspots. Corresponds to wave propagation from middle latitude to the equator. Characteristic sloping structure is not visible here. Visible on the diagram signal clearly contains the contribution of several oscillations, including 22 cycle dominance. However, after the allocation of this contribution by method of wavelet analysis, chess structure is visible in the diagram instead of propagation waves. In each of the solar hemisphere, two rows of spots are visible. One of them is visible near the equator, another is visible in the middle latitude. The spots change their polarity from cycle to cycle. In this series of the spots are shifted relative to another series of spots by a quarter period. Minimum module of the field is located below the maximum module of the field and vice versa. We considered such model with meridional circulation and term. This term corresponds algebraic suppression of the helicity. We can see butterfly diagram for toroidal magnetic field for dynamo number minus 200 and 100 without meridional circulation. Here shift is small. If meridional circulation equal some value, shift is similar such shift. It is natural to expect that different against the spreading of dynamo waves, meridional circulation can obscure the picture of the spread and puff out chess structure. We have shown that the appearance of chess structure in butterfly diagram of large-scale magnetic field can be described in the presentation of the dynamo theory. It suffices to consider the simplest model of the Parquet dynamo is near the generation boundary and assume that the available observation have a boundary nature. So the contribution of very weak fields is lost in the noise. If we assume the existence of meridional circulation directed against the propagation of the wave activity, meridional circulation not only helps to substantially prolong the cycle, but also makes the chess structure is much more noticeable. Next, the problem meridional circulation and helicity. Until recently, no observation tools were available that determining the alpha effect, so that models for the solar dynamo wave based exclusively on estimates of the alpha effect deduced from primarily physical principles. It has recently become possible to estimate the magnetic contribution to the alpha effect using observational measurements of the so-called electric current helicity in solar activity region. Since the magnetic and electric current helicity are proportional to each other, we are basically interested to the qualitative behavior. And we can plot them on the same graph without specifying which of these two helicity are considered. Thus, we can compare the helicity which calculated from Parker dynamo equation which observed this observed helicity. Helicity shown with help colors, and red correspond plus, sign plus, and blue we have minus. It is here meridional equation equal null, here equal 1. It is here toroidal component of magnetic field shown with help solid and dashed lines. The latitude times distribution of helicity is comparable to the whole polarity rule. Structure of butterfly diagram of helicity and toroidal magnetic field and structure of the wrong sign area depend essentially on the meridional circulation. Such wrong sign area is observed by Zhang. I research behavior of toroidal component magnetic field near poles with meridional circulation. It is a simple solution such system. It is toroidal component of magnetic field. It is function by Watteke function. The latitudinal profile of meridional circulation affects the configuration of incident and reflected dynamo waves. For such meridional circulation, the field near the pole is superposition of incident reflected waves. The velocity of the substance cannot change the direction of the wave. For such meridional circulation, field near the pole is a superposition of standing waves. Possible configuration: the incident wave field change sign and the reflected wave no change. There is a time when the field has same sign in the incident wave and in reflected wave field has another sign. In this case, the amplitude decreased by 2 order. This result can be explained by the fact that the incident wave with a new sign comes to pole and reflected wave is from the previous cycle. The incident wave appears at latitude about 75 degrees. Further research. I have studied the problem of the behavior of the magnetic field in the case of two-layer medium in the convective zone of the Sun. Such a study is necessary to know how the parameters of the layers affect the length of the solar activity cycle. I have discussed possible options for the inclusion of meridional circulation in this model and investigate the influence of meridional circulation on the nature of description and configuration of the dynamo waves. I have studied the problem of the behavior of the dynamo waves near the solar equator. I have studied the problem of inversion of the magnetic field in the Earth. It is planned to begin studying the process of generation with symmetric magnetic fields in spiral galaxies. The example found in the Cobb equation for 12-hour medium, I solved it equation. It's my prize thing for rotation.
Thank you, Anna. Interesting talk. Any questions, please? So one of the things you mentioned is that the cycle lengths can become significantly longer. Is this something that has previously been found in other flux transform models? Maybe somebody of the audience would know the answer to this. Is it something this has been seen before? No? Yes?
The first paper by Chaudhary, Shushila and Dikpati, which in 1995 as well as Dooney in 1995, they introduced this meridional circulation with flux transport dynamo, and the reason was to counter the dynamo wave in the opposite direction. But then that idea is not redundant because now it has become flux transport thing. But then the idea was that the meridional circulation will counteract the dynamo.
Yeah, it has the lower the meridional circulation, the longer the period, right? It's proportional.
Yes,
So higher the velocity.
Yes, yes. Inversely proportional.
Inversely proportional.
Inversely proportional.
Inversely proportional to the cycle.
Is that the same direction that you also found? I mean, when does the cycle period become longer in your model? With stronger circulation or with weaker circulation?
Circulation.
Sorry?
Strong circulation, not reversal.
It's not what?
Reversal.
If there's strong circulation, there's no reversal, you say, yeah? Right. That means, that sounds like the cycle period becomes longer if you have strong circulation. No?
So that is really countering.
That would be the other sense, yeah? Right. I mean, the reason perhaps for possible discrepancies is because the model apparently lacks also the return flow, right? You have only one sense of flow, namely the one to the
It's just theta dependent, right? It's not R dependent.
yeah, so there's no return flow. So that's not the problem?
The theta component of the meridional circulation that shows not in R. It's V theta, not V R.
Yeah, but there's the return flow.
Okay.
Sure, it's a 1D model. It's like a wing.
Was there any final conclusion on this, or what did you say? Didn't hear it down here. Okay. Is there any other question?
Does the meridional circulation have a relation to the amplitude of the cycle?
The question was about the amplitude, effect on the amplitude of the cycle.
No.
No.
There's no influence.
Would that be something the others could address who have done two-dimensional models? What is the effect on the amplitude?
At least from the model that we worked, if we increase meridional velocity, the amplitude increases.
Actually, it's not linear because
No, it's not linear.
It's not linear. So it depends on in which regime you are, whether it's advection dominated or diffusion.
Exactly. The idea is basically that in the bottom of the convection zone, meridional circulation brings more field to be advected to that part. It also decreases the period because of that. At least in its model.
Okay. Thank you. Do you have a comment?
Am I allowed a stupid question for the people, the past two talks we have? It seems like you can devise different models that do a good job at reproducing some features of the solar cycle. Does this model is there anything in this model that depends critically on how the dynamo is generated? Okay, the fact that this works like this or like that, does it give you any hint on what's going on as far as mechanism or processes? Is there anything where you can say, well, if I change this a little bit, I won't be able to do that? Or isn't that asking too much? Because you got low dimensional behavior anyway.
So, what do you expect to? I don't understand well your question.
The question is, I think, whether one can learn anything about possible constraints on the model, such that the model actually works, and otherwise it wouldn't work. But I think there's lots of answers to this, no? You want to begin?
Well, I did some changes in the thickness of the taco plane, and it could be it could do some difference. It could do some difference in the distribution of the toroidal fields. So if the thickness of the taco plane is very thin, and the flow is going little deeper of the convection zone, you don't generate so strong magnetic field there at the pole. So you only generate magnetic field at the equator, and this could help also to get a more realistic butterfly diagram.
I mean, there's maybe more things that, if you want to make this model work, and if that's the only chance, then you would learn that there must be a circulation all the way to the pole and then back again at the bottom.
Yeah, for instance, if there
must not break up into a small
that's associated with,
I would think.
Once you finish fitting the parameters, does that give a time scale that people know exists and is there? Or?
Another thing I think is that the alpha effect must be concentrated near the surface layers. Otherwise it wouldn't work.
Yeah, it's for example, for our model it's Babka-Plate and alpha effect, so it's surface.
And the third thing is that the
Diffusivities.
magnetic diffusivity must be about 50 times smaller than the formula that you wrote down earlier today. Maybe other things?
If you kill differential rotation, you kill the dynamo. So the dynamo uses a differential rotation for the sun. There's a differential rotation profile inserted in the model in order for it to produce toroidals.
Okay. Okay. Any further comments? No. Then we thank Helena again. Now the talk by Andrew Bagley on a reconnecting flux stroke dynamo.
Just write flux stroke dynamo.
What?
Just flux stroke dynamo. Change the title.
Fluctuating dynamo.
Flux stroke dynamo.
What?
Flux stroke.
Flux stroke.
Yeah. Other issue.